Hello, everybody. Welcome to our LinkedIn webinar event, keynote, however you want to call this, how visual robot data audits enhance body and white efficiency. I'm very glad that you could make it. I hope that you all can hear me well. If you have any questions along the way, feel free to drop them in the QA section. I'll answer them at the end. We are recording this event and I will send you the link and the presentation afterwards. So yeah, since I know your time is valuable, let's get started. I'll begin with a quick introduction of our company and myself, and then jump straight into the topic. So who are we and why did we invite you to this event today? My name is Arne. I'm the Chief Operating Officer of Dressler Automation. And as you can probably hear from my accent, I'm from Germany, which actually makes a lot of sense as we are a German-American company founded in Germany in 1970 as an office for engineering services. I would say until 2020, we had the classic path of a system integrator from hardwiring cabinets to electrical planning, PLCs programming, and of course, robot integration. Our focus has always been on global body and white projects, mostly for German OEMs. That's also why we opened a location in the US, in Chattanooga in Tennessee, back in 2010 to better serve these global projects. And there in Chattanooga in around 2019, we developed a tool to improve our own robot programming, which turned out to be extremely valuable for manufacturers. So we launched this tool as a commercial product in 2020. And because of this technology, we invited you to this event today. Okay, so what is it all about? As I mentioned, we have decades of experience in body and white, especially in robotics. We've integrated, programmed, and optimized hundreds of robots for OEMs, but also for global tier 1 suppliers. And in all those projects, we came across so many different methods, mostly Excel spreadsheets, that people use to keep track of robot process data. And we learned the hard way that robot documentation almost never reflects reality. And I'm sure that sounds quite familiar to you. It's just the standard situation and it's frustrating for a lot of people. Yeah, but why is this a problem? Or is this a problem at all? Well, it is. In our experience, the impact of inaccurate robot documentation is significant and often underestimated. So imagine the valid names or IDs or however you call them, they are differently in the robot than in the documentation, or the glue parameters are wrong. If that's the case, a small change to the weld or to the glue controller or to the robot, of course, suddenly causes serious production errors. In German, we actually have a word for this, verschlimmbessern, which means making something worse by trying to make it better. So in order to solve a problem, you could introduce a second one, or a weld disappears for certain variant combinations. We've seen this surprisingly often. The worst case, of course, is the recall. And once an error shows up, it's often not easy to trace it or to fix it because nobody really knows when the error has been introduced. So nobody really knows which bodies are affected. And to analyze the problem, production usually needs to be stopped to guide the robot manually from point to point for root cause analysis. Takes forever, is highly complicated, and requires specialized staff. But also new integration suffers from this, both in planning, but also in commissioning. Because if nobody really knows which processes are being executed by which robot, it's nearly impossible to simulate new processes with matching cycle times. Talking about simulation for most robots, incorrect frames make analyzing them in the simulation impossible anyway. And during commissioning, it's really difficult to understand which robot was programmed when and how. The quality of those programs is usually verified randomly, and in the worst case, the already running production is also affected and gets worse while integrating a new model, and nobody notices before it's too late. And those are just a few examples, but I hope you get the idea. When robot documentation is inaccurate, which is always the case, more or less, it leads to serious problems. And in our experience, these problems are responsible for far more cost than people assume. For troubleshooting, evaluations, remeasurements, everything related to robot data management, every single robot gets analyzed for at least 10 hours every year. With hundreds of robots, that's a lot of work and a lot of unplanned downtime. Not to mention the bad parts that needs to be reworked or to be scrapped because of wrong controller settings, off location welds, or incorrect weld angles, like I just mentioned. And all of this is happening in an economic environment of increasing pressure, cost pressure, shorter and more complex production cycles, and of course, layoffs. So we have less people taking care of more and more data. But to improve this situation, we first need to understand what's causing inaccurate robot documentation in the first place. So this is, of course, a quite complex answer. I'll keep it as short as possible, but I'm sure that most of you will be familiar with this anyway. So the biggest problem is the lack of consistency. Too many people in the plant, including external integrators, and everything is constantly changing. For example, a lot of small changes are made spontaneously because the line must be kept running and the documentation is never updated. But if they are tracked, typically changes are tracked in Excel spreadsheets or something else, often in different versions, and there's no clear workflow. There's just no single source of truth for all the relevant past and present planned and actual data. It's just a mess. And we've seen some crazy workarounds, sometimes with PowerPoint, which is, of course, yeah, well. On top of that, there's just way too much data, and it's far too complex. It's not easy to access. Many manufacturers back up robot data once a day at least, but reading this code-like information takes forever, and only a handful of people can do it. The biggest issue, though, is frames anyway, like I mentioned earlier. If the robots aren't properly calibrated, the code doesn't tell you that much, and the robot programs can no longer be loaded to the simulation. You could, but it doesn't really help. And that's actually very common. So changes are often only checked individually, manually, when it becomes absolutely necessary. And as I mentioned, the line has to be stopped for in-depth analysis. Robot code has to be compared manually. In short, it takes a lot of time. We know some plans that employ several people for doing nothing but keeping robot process data up to date, and they still don't catch all the deviations. It's clear that modern body and white environments need a solution, a new approach. They need accurate robot process documentation. So in other words, to improve efficiency, we need documentation that actually reflect reality. Some people would call this a digital twin. To understand the requirements for such a documentation, we more or less just have to flip the problems we just discussed. So instead of inconsistency, we want consistency. We want our documentation to be consistent, always the same, regardless of who changes or analyzes which data, when or where. One standard, one source, one system. Instead of inaccessibility, we want accessibility. We want everyone to have the easiest possible access to the data in a way that even untrained staff can understand it. This means we need a way to handle even the most complex frame issues. We need to solve this because at the end, it has to be simple. And we want to minimize the manual effort as much as possible. Nobody has time to analyze robots or to keep track of changes manually. We need automatic documentation and evaluation. That means automatically extracting data, analyzing it, detecting deviations, and distributing it throughout the entire plant. And we need to be able to easily understand changes over time. So we need something, like a timeline. All this is necessary to achieve robot process documentation that is always accurate and easy to read. Something that we haven't seen in the industry besides, well, I think you've probably already guessed where this is leading. Besides what we built, we call it RoboLive Visual, which is an Industry 4.0 tool that visualizes all joining positions and robot parameters automatically. I mentioned in the beginning that we started on this back in 2020, so we already have a solid understanding of how this impacts weld shops, body-in-white environments in practice. To emphasize the contrast, I'm referring to the slide we already had earlier again. So without an accurate documentation, small modifications quickly turned into major problems. Having an accurate documentation, we can clearly see that it's much easier to plan and verify adjustments. As a result, the modifications actually have their intended effect. Imagine making adjustments to the weld controller based on up-to-date weld IDs, for instance. And if issues come up, they can often be identified before they affect the actual production and solved much more easily. There's always a clear record of when these issues were introduced and a clear visualization of their root cause. And also integrating a new model is significantly easier having all relevant information available. We estimate that we can reduce the manual effort for robot data management by at least 75%, that we can cut unplanned downtime due to robot programming issues by half, and reduce scrap by 50% as well. Of course, scrap that is caused by robot programming issues. To sum this up, in our experience, accurate robot process documentation can increase OEE by up to 3%. In LCV production, that number is even higher. Okay, so that was all very theoretical. In the next step, I'd like to show you how we actually do all this. Right, so our technology is able to extract all the relevant data completely automatically. We just need robot backups from any robot, KUKA, Fanuc, ABB, Yaskawa, to name a few. This data is then analyzed and integrated in a custom client. And this client can be installed anywhere, which means everyone has access to RoboLive Visual from anywhere, and anyone is able to evaluate robot programs in seconds. To make the evaluation as simple as possible, RoboLive organizes all data and visualizes every joining process in a 3D environment. We use the product CAD to accurately position all the processes, so it's even easier to understand. And with all the processes, I mean literally all of them, all kind of joining technologies, spot welding, gluing, hemming, clinching, gap filler, you name it. With the visualization and with the filtering options, variance and line overview, the parameter table, anyone can easily filter by robot, search by process name, and whatsoever. So RoboLive is able to visualize a lot of important information. Like I just said, the joining positions over here, but also the tool orientation, for example, to trace changes to the weld angle, but also seams like laser and glue, including their directions. You can see the little arrows. And by using what we call labels, RoboLive can also display any other robotic parameter directly in 3D. For example, movement points, order, glue program, weld ID, whatever information the robot contains. And all of this can be analyzed interactively in 3D from anywhere. To make the analysis even easier, RoboLive automatically detects and highlights deviations. So incorrect process positions, for example. Of course, we can define a custom tolerance. The worst case, deleted processes, which, by the way, happens surprisingly often, as I think. Incorrect process names, which is a very good example. It's crazy how often a robot programmer copies and pastes robot code and forgets to change the process names, and suddenly there are mixed or multiple used IDs, which eventually lead to faulty modifications, like I mentioned earlier. Yeah, what else? So incorrect parameters, of course. As an example, are incorrect glue programs. They are almost always wrong and cause incorrect adjustments to the control. Yeah, and all of this only works because RoboLive is able to compensate for base and tool frame issues. In other words, RoboLive works even with poorly calibrated robots. But RoboLive's most important feature is that it automatically detects and documents, monitors changes. This means you can easily use this timeline below to trace exactly when which process were changed and how. Imagine, for example, over the weekend, there is a contractor making some cycle time optimizations or whatsoever. And on Monday, you want to know what happened during the weekend. Without RoboLive, I don't know, analyzing the actual robots, that doesn't really make sense. Simulation isn't useful either. So most manufacturers just start production and hope for the best. With RoboLive, it's just 2 clicks and everybody knows what has been changed and if those changes are how they should be. And of course, this is similar during the the entire commissioning phase. RoboLive automatically detects which robots have been newly programmed. If there is an issue, you will immediately know about it. And you always know exactly the progress of the entire robot integration. This way you can make sure the contractor delivers the ideal robot programming by start of production, because you can show them the errors visually. And I can tell you they hate this because they lose the blame game. Yeah, and this is how RoboLive has a different impact on all phases of a production. So ramp up is easier because everyone can make and verify data-based decisions. Maintenance is way easier, of course. And I already talked about planning, designing, integrating new models into an existing production. Ideally, of course, RoboLive is used right from the start, but it also makes sense to set it up for a production that's already running, either as a one-time analysis to detect hidden robot programming issues, or as a running on-site system. For example, one customer recently purchased RoboLive for a model that was close to the end of its production life, simply to make the planning and integration of the new models as smooth as possible. Okay, so to wrap things up, documentation of robot processes in bodied white is almost never accurate. Nobody really knows who programmed which robot, when, or how, and if it's like it's supposed to be. This creates a huge amount of manual effort and unfortunately has a negative impact on production quality. Which is why we developed RoboLive Visual, a system that automatically visualizes joining positions and robot parameters. This works in any environment with any robot, any joining technology, and any standard, and it's available from 9900. If you'd like to see it in action, feel free to schedule a free demo. Just scan the QR code or go to robolive.info/bookings. And yeah, that's all I wanted to talk about. Are there any questions in the chat? Not so far, no. Do you have any questions? I hope everything I talked about was clear and understandable. Of course, like I said earlier, we will provide you with the recording and with this presentation.
I think there's a question in the Q&A.
Oh, I don't see it.
Yeah. Someone who asked, oh, go ahead.
Yeah, okay, I got it. So, is this data live? Well, not really. So, we need a virtual machine that processes the data. This can take some time, of course. It's a huge amount of data, but this virtual machine can run like everywhere and can extract the data in a frequency that you want. So technically, we could do it several hundred times a day. In our experience, we recommend extracting the robot information at least once per shift, so that every shift knows the base of their current robot programming. So it's not live per se, but it's pretty up to date. The robot data, we can pull it from any sources, more or less. We, like I said, we just need the robot backups to process on a virtual machine. We can pull this data automatically via FTP or SMB directly from the robot controllers, if there is the RoboLive server, the virtual machine installed on the production network. But basically, we just need access to the robot backups. So if it's not possible to access the robot data directly, we can pull this information from any other storage. So if you, for example, back up the robot backups once a day, we can always access this information as well. You can send us the information. This can be done remotely. We can install a physical server that is fed manually, so we just need access to the robot backups. Okay, if that's everything, let me quickly go to the next slide, the last one. Okay, so I hope you enjoyed the presentation. We'd love to meet you in person sometime. As I mentioned, we will send the slides and the recording. And yeah, I wish you all the best. Take care and hopefully see you soon. Bye bye.